Okay, does this match your sheet?
Yeah.
The chance of getting a good yield on a farm, on your farmland this year is 70% if you get 2 inches of rain in July. The chances of getting 2 inches of rain is 65%. The chance of getting a good yield if you don't get 2 inches of rain are 50%. What's your chance of getting a good yield? All right, guess which one this is. Okay, what is our first split? What do we want to do? Our first situation. We either do what or what?
Rain or no rain?
Get 2 inches rain. Yep.
Yeah.
Or don't get the rain. Okay, what we got here? What's the chance of you getting that rain? The chances of getting the rain is 65, which means, what's your odds of not getting it? 0.35? Okay, and then split. Now you're either going to have a good yield on your farm or a bad yield. Okay, the chance of getting a good yield is 70% if you get the rain. So, a 70% chance, which leaves 30. Okay, if you don't get rain, the chance of getting a good yield if you don't get the rain is 50%. So that's a 0.5, then that's also a 0.5. Okay, can you do, what? The girls do the top? Boys can do the bottom ones? Actually, the bottom two are both the same then, right? What should all of those add up to if I wanted to? They would all add up to 1. That's 100%. Okay, what's your chance of getting a good yield? So which scenario was good? This scenario was a good yield with the rain, and this scenario was the good yield when it didn't rain. What should I do mathematically with those values? I need to add them. Okay, 63% chance. Okay, the probability of scoring a goal is 2 out of 11. What are the odds against scoring? So this is how you're going to think to write it. Yeah, I like that number, Jonathan, that you had there. Odds against scoring. So how many would we not score versus how many would we score? So Jonathan, what did you think about with numbers?
I just minus 11.
So you got 9 of the shots that you did not score versus 2 scores, right? Okay, the odds of getting to work on time is 1 to 4. What's the probability of you getting to work on time? 1/5. Because this means one time you're on time to a ratio of 4 not on times. So how many events altogether? 5, right? Okay, so just like here, those add up to the bottom probability number, right? Okay, your family's lining up for a photo. There's 6 members, 2 parents, 4 children. What's the probability that the parents will end up beside each other in the photo? Okay, so let's talk about the parents being beside each other. How many arrangements is this going to make? So if they are beside each other, what do you want to do in this? If they're beside each other, which kind of strategy is this one? Group arrangements, and then within the group, right? So how many things altogether now are you moving around? 5. Then what could the parents do within themselves? 2. So that's this situation, but we need to do a probability. So we need to divide by all of the possible situations. So not with this situation, but what could possibly all happen with 6 members of a family? 6 factorial. So this is the arrangements of my situation divided by the arrangements that could, no matter what, all happen. Okay, I'm guessing you'll want to do that as a decimal or percent, or I'm not sure, or fraction, whatever you want. Fraction, I like fractions, but okay. Were you gonna ask me something?
Yeah, I got.
What? So I did that wrong? What?
Maybe I just put on my calculator.
5 factorial times 2. Oh, 240. Is that what you got there?
Yeah.
Wow, I'm not sure what I did. What did I do? Okay. Thanks. Now that's what you matched with, or what? That's good?
Wait, I can.
Oh.
Yeah.
That's what you got? Okay, thanks. What do you think I typed? I don't know. 5 factorial?
I was gonna redo my calculator.
I must have hit a divide by 2. Yep. Instead of a times by 2. That's what I did. I have fat fingers. Those buttons are really, really close together. Okay, 6 boys, 6 girls, basketball team. What's the probability that the 5 girls would be chosen for the starting lineup? Okay, so let's talk about just this situation. How do you choose 5 girls to be in your starting lineup? What are you going to write? 6, choose 5. There's 6 girls. We're going to choose the 5 girls. This is a probability, so we have to divide it by all of the ways we could have chose a team. So without this situation, what are all the ways you could have chosen a team?
12.
Yep, 12 C5. You could have picked anybody and picked 5 people. Okay, I'll do this a little slower so that I make sure I get some correct answers, hopefully. Somebody matched me, right?
Yeah.
this our next page?
Oh, we were 65.
There is 120 students in grade 9. The probability the student takes music is 50%. The probability that the student is on a sports team is 60%. The probability that the student doesn't participate in either is 10. How many participate in sports only? Which method was this?
Venn diagram.
Venn diagrams. Yep. So 2 bubbles. Looks like we're going to have a music and a sports bubble. Okay, 50, a 60, and a 10. You guys know that one of those values always seems to go somewhere. Which, the 10. The 10 can go somewhere. So probability that they don't take either is 10. So that's going to be on the outside of the bubbles. Okay, what's the percentage of inside the bubbles? I'm going to need 90%, right? Okay, there was a 50% plus a 60%, which is 110%. Ooh, that's too much to put in my bubbles. So then what? Subtract leaves me with a 20% overlap. Okay, now we'll go back to the music. So music needs 50, which would mean this is 30. Because now I have a 50% inside there altogether. And 60% with sports. So now this needs to be 40. So the final question was, how many students participate in only sports? So what would you answer with that one? 40%. Okay, you create a PIN number using 4-digit code, the digits 0 to 9 with repetition. What's the probability that you and your friend have the same code? Okay, so 1, 2, 3, 4. How many different codes are possible? 10 options. 10, 10, 10. So there's 10,000 codes. So what's the probability that you and your friend have the same? How would you write that as a probability? 1 out of 10,000.
I guess so.
There's only one way for your friend to have the same code as you, right? Okay, you create a 3-digit code using the digits 1 through 7. So maybe I'll just list these out. Repetition is not allowed. What's the probability that the code will be divisible by 3? What's that? Oh, no, we have to do way more work than that. Okay, so it's a 3-digit code. How do you make something divisible by 3? Oh, this is a hard question.
Did you skip the 6?
What? Oh, why? Yeah, why didn't I write a 6? That's a good question. You know what? I'm going to change this question. I'm going to change it to divisible by 2. Because I feel like you will not know how to do that other one. Okay. So divisible by 2. Ready? How do you know if something's divisible by 2?
If it's an even number.
Okay, if it's even. How do I know if it's even?
If the last one is even.
If the last one is even, then it's even. Okay. So, what could I put here?
2, 4, 6.
So there was 3 options you just told me. I could have put a 2, a 4, or a 6. And repetition is not allowed. So if I had put something there, how many options will I have in my first position?
4. Or, wait.
If I put one thing there.
Oh.
So now I only have 6 options here and 5 options there. Okay. Maybe that was a little confusing. So you could have done scenarios. If it ends in a 2, then you could have done that, 6 and 5. Scenario, if it ends in a 4, right? Or if it ends in a 6. Right? Adding those up is the same thing as me doing this because it's timesing it by 3 and there's 3, right? Okay, do we have a value on that? 6 times 5 times 3? 90. But this is a probability, so this is the scenario if it's divisible by 2 divided by all possible scenarios. So I need a 3-digit code.
So 7,
7. But I think we still need to stick to the repetition thing.
Oh.
Repetition is still not allowed, but I don't have to worry about the even part.
7, 6,
7, 6, 5. So without thinking about the even, but still with the repetition.